My name is Ashton Drew, and I'm a data analyst. I'm a private consultant, work for KDV Decision Analysis, which is working for myself. But my background is actually in fish and wildlife conservation and decision planning, decision optimization for natural resources, a lot of spatial modeling, individual-based modeling, that kind of thing. But more recently, I worked in the applied ecology department at NC State for multiple years, and we kept developing piloting tools, decision tools for natural resource managers and fishermen and foresters and farmers, which would end up in academic journals, and that's where they would kind of go to die. And I had people who I worked with who were excited about the tools and wanted to use them. Most of our coding was done in R, so I started learning some of the interactive tools in R as a way to serve up these tools in a much more usable way to the people that I worked with. And then it sort of became what I do for money as well as what I do in my free time. And so for the next 2 hours, my goal is really to give you a high-level overview of some of the interactivity, the options that there are in R, the tools that are there. But we're also going to work through some specific examples of code and output you're going to leave with little interactive plots and graphs and a little shiny app is the goal. It was labeled as an intermediate workshop, not because I assume that it's intermediate for your shiny or your interactive tool skills, but rather that you're already a little bit familiar with R syntax. So I won't be explaining, I don't have to explain how to go and find and install a package if you don't already have it, or if you're seeing sometimes square brackets, sometimes round parentheses, and sometimes curly braces, that you have some idea of what's going on in R. But the examples that I'm giving you are really simple. And for those of you that do use R, if you're finding them so simple that you're getting ahead of what's being presented, feel free, you've seen the library that we're using, to go to the help section and start modifying it on your own. I'll escape from this real quick just to show you that I did put up everything this morning on my GitHub repository, which is Ashton Drew, no spaces, no dots, no dashes, and it's in the PyData demo. So you can also download these slides if you're maybe falling behind and want to be able to look at the code that I flipped past. The PowerPoint is on there, but also some of the R scripts. So you could, if you're ahead, feel free to go faster and break it. You can always get it back from here. So. And then, like I said, the objective is that we're going to build some simple interactive plots together in an app, and that you'll leave with resources and tips to keep learning on your own. Typically when I teach, I do a lot of teaching, but it's usually classes of 3 to 6 students, and they bring their own data, and we start from scratch with them having no knowledge of R to building an app over the course of 5 days. So this is my first time trying to condense a lesson into 2 hours. I do invite, therefore, feedback by email or however LinkedIn messages afterwards on what worked and what didn't. This will be my first. We'll see if it's first of many or first of last or how things go. Hopefully fun though. And also feel free to ask questions along the way. If people start having trouble with their code, it's going to be hard with this many people. I don't have a TA to walk around and help you. Real quick, is there a show of hands of people who are generally comfortable in R that use it? Okay, so most of you. So maybe if you didn't have your hand up, and you saw someone next to you who did, feel free to cozy up to them and ask a question if you're running into a challenge. The biggest challenge I anticipate having maybe with this many people is just if people have an older version of RStudio to start, or an older version of some package where there's a dependency is a very likely possibility. Otherwise, it's just that you have a comma or a bracket in the wrong place, or you've capitalized when it's case sensitive, typically. So the instruction methods, we're going to be using R. It's going to be assuming that you're using RStudio. Packages that I assume that you have, so if you don't have them, you might want to download these while I'm talking. ggplot2, Shiny, Plotly, Leaflet, and DT. And we're going to use just one of the built-in data sets, the Quakes data set, which is earthquakes in Fiji, or near Fiji. And we're going to build some standalone little widgety tools, and then we're going to embed them in Shiny. We'll build the code as we go, starting simple, and then we're going to keep inserting or rearranging one more little piece of code in this one, from this one view. And like I said, actually, I said they'd be on GitHub soon, but I actually got them up there, so they're there now. Oh, sorry, it's Ashton. My account is Ashton Drew, so ASHTONDREW. No dashes, no spaces, all lowercase. And then it's PyData demo repository. It should be there. Did anybody find it? Okay, good. So basically, interactivity in R, and again, my background is not computer science degree, coding degree. I came to this by simply using it. But when I think of what I'm writing code in R, building things in RStudio, and then I'm using various packages to be able to transcribe these into JavaScript, connect them to JavaScript libraries. If I knew more JavaScript, HTML, CSS, there'd be way more things I could do to make them pretty. I rarely need to make them pretty in the context I'm working, but that's basically what's going on. And these, there's a library called HTML widgets, which is kind of a framework through which people are building all these customized packages and widgets to connect to JavaScript libraries. The three, like I said, we'll use our leaflet, which is for making maps, Plotly for making graphics, and data tables, or DT, which connects to the data tables JavaScript library. And you can view these on your desktop. You can view them and embed them in Markdown. You can embed them into your Shiny app, as well as just using these smaller packages on their own. And so the cases in which I use them are somewhat specialized. These are the three sort of primary cases that I end up using. Our interactive product, Shiny, is either it gives me data exploration in an organized framework. I deal with people who disagree on what data should be there or what assumptions should be used in a model, so we can play with that very quickly. For delivering large volumes of data, and where each individual user needs to see a different subset, like they're farmers in different regions or who use different techniques, and we've made huge models, but they only want to see their little subset. And a lot of what I do is scenario analysis, so we're, again, testing assumptions or comparing alternatives. So I'll build a Shiny where you can build your own version of scenario one with your beliefs and values and preferred assumptions for parameters, and someone else can build their competing one. You can compare them side by side. And a lot of what I do is quick and dirty because it's in workshop settings where I sit all day and people are fighting over some environmental issue, and then I take away and code at night, maybe with simulated data, maybe with data they had, to bring it the next morning so we can say what really matters in this discussion and debate. Can we say that this assumption is having no effect? You know, the percent land cover doesn't really matter, but this other issue really does. So these tend to be almost black and white. I'm not making them pretty because I'm making them at night to show the next day. But you'll see in the help that there's lots of ways to make them pretty as well. So the earthquake Fiji data, or the Fiji earthquake data that we'll be using is called Quake or Quakes. I thought it was Quakes with an S. You'll know very quickly if you try to go head Quake or head Quakes or summary. But it's the location of 1,000 seismic events greater than 4 magnitude since 1964. They didn't give an end date. I assume it doesn't go to 2016, off the coast of Fiji. It just has 5 variables. I chose it because it has Latin long, so we can use it with leaflet to make a pretty map. Then it has depth and magnitude and the number of stations that are reporting a given quake. And it comes out of Harvard. So first, we'll go straight into building things, which is the goal for today. So the first 3 tools that we'll look at I think of as standalone tools, because you don't need to embed them. You could just make it to be your own little interactive graphic on your desktop, or you could save it as a HTML to share with someone or embed someplace else. And the first one, so you'll need to load up a library, have the DT package, and everybody should have RStudio open, hopefully. If you want to go look at these, the links are there to look at some of the documentation. But DT gives you interactive web-based tables via the JavaScript library data tables. You can feed in matrix or data frame objects, and they'll be just transcribed to HTML tables. And they have a bunch of little filtering, pagination sorting just by default. but then you can, again, make it fancier. So if you have your, you can start with 2 lines of code, library DT, data table quakes, and you'll have an interactive table, and you've built your first R interactive object. And what I'll pause every now and then, because my hope is also that people will click on things, which will be boring in the video they're making of these sessions. But you should be able to see that you can choose how many, there's 1,000 records here, you can choose how many entries are being shown at a time. If you click on the little gray arrows by each of the column names, they'll sort from top to bottom, just ascending, descending. If you wanted to just search for quakes that were 6.0 magnitude, if you type a 6.0 in the search box, it'll pull up just those records. So not too much there. It took the default column names from the data frame that we fed it. It added this column of row names by default. If we want to do something to make this a little fancier, we can try a prettier version. Like maybe we want to actually give it sensible names as opposed to abbreviations. Maybe we want to get rid of those numbers. Like our quakes don't actually have a number order. So we can say row names equals false. We can give it some column names that make more sense. If we want to add a filter, a better filtering option than just this search command, we can say filter equals top or filter equals bottom, and it'll add this row of underneath each of the columns, so you can be specific. Before, if I had typed in 6.0 and I happened to have a depth or number of stations was also 6, it would have been sorting for everything that equaled 6. This way I can be more specific. And I gave it a caption, Table 1 Earthquakes near Fiji. So very simple. And this, if you put, so if you were building, say, a markdown document that people were going to view as an HTML document, instead of putting in your printed data frame or the head of your data frame, you could simply put in the data table object, and then people could search and sort through that table instead of a static table. So that's the simplest. And everybody, most people nod, they were able to make things go. Okay. So next, looking at library Plotly. Plotly has a huge amount of stuff. It's almost in my mind. I might start using Plotly more than Shiny sometimes for some of the things that I need to do, given how much it's grown recently. I should mention these 3 packages are all have been kind of picked up or adopted by RStudio as well. So they're getting, I chose them partly because they also have a lot of documentation. Some of them have cheat sheets. They have pretty extensive conversations going on all the help channels. If you had a problem, you're likely to find someone quickly responding. But Plotly is interactive, web-based 2D and 3D graphics that links to the JavaScript Plotly library. By default, if you give it no other commands, you get a panel that gives you a legend, pan, zoom, pop-up text, etc., which you can then modify and extend. It's easy to combine data manipulation and visualization functions because it allows the pipe command. So you can have very condensed code, which is nice. It's flexible, and one of my favorite things with it is that if you already use ggplot2 as opposed to, say, lattice or base for most of your graphics, they have command ggplotly. So you simply work in ggplot2 like you normally would, make it as pretty as you want with your familiar commands in ggplot2, and then take your object that you created, your ggplot object, and just put ggplotly, name of that object, and then it's your graph, but interactive. And then you can continue to edit it if you want. But again, you can view in RStudio or a web browser. You can embed it in Markdown or Shiny. And to publish, you end up with choices. So they actually also offer, so we'll see that in Shiny, there's Shiny Apps.io where you can publish through their service, but Plotly also has its own service, or a free service, which offers minimal support, but then there's some paid services as well if you were creating a lot of graphics. And they do have increasingly options with the rPlotly for creating dashboard type. So one of the advantages was that these were all sort of standalone. You weren't creating dashboards, you were creating a table, or you were creating a graphic that you could then embed in Shiny, where you'd have more of a dashboard type environment. But Plotly is, the R connection to Plotly is increasingly allowing its own sort of dashboard environment creation. So I'm gonna, these all develop so rapidly that I don't look at them for a few months and then I go back and there's 10 times the content. But if you want to build just the basic interactive graph, it's almost as easy as the table. A few more lines. Library Plotly, and it's plot_ly for the function. Give it the data, quakes. Tell it which is your x and y for us if it's going to be a scatter plot. And then you have to give it a mode, which would be like lines or markers. In this case, we're making a scatter plot, so we'll say markers. And if you make this and then you start mousing over your hovering over your dots, you'll see that they bring up some data about those dots. You can also go through and they have a number of actions. You can zoom, move around on your plot. There's a select tool, which right now will select things, but these are events, and we haven't linked that event to doing anything, so it's not very exciting, but you have an interactive plot. But if we, and we'll wait a few seconds, but if we want to make it something prettier, something nicer, maybe give it some color. This is where I switch immediately to, I use ggplot for most of my plotting. So I'll say, okay, well, I can make this prettier with ggplot. I can use ggplot to give it its data, its aesthetic, and its geom. I can add my own colored gradient scale, add some labels, X and Y lab, a title, and then wrap it with this ggplotly command. So I'm giving it my ggplot object, but I also want to have this pop-up tool still, so I give it this second argument for the tooltip, which says I want to see my X variable, my Y variable, and the color variable showing up in my tooltip. So now when you mouse over, you see different options. And this is where I'm not going into super deep detail unless we get all the way to the end and want to come back and look at these. But if you look in the help for ggplotly, you'll see all the different arguments that you can add in here. So if you want to change your fonts, and if you want to change, like right now it's using the default column names for that tooltip. There's ways to modify that. Pretty much everything is modifiable, either within the ggplot, so you could use your text commands, or through the Plotly commands. So it's pretty flexible. The third one that I'm showing, just with these standalone tools, is leaflet. And make sure that if you want to run this code, there's multiple leaflets. So leaflet without the capital R on the end, the one that's just library leaflet, package leaflet. This is the one that's supported by RStudio. There's a number of other packages out there that also connect to the leaflet JavaScript library. But so this creates interactive maps. It'll render spatial objects. So the spatial objects are the SP objects that come from the SP package with your geodata, or the data frames with a lat-long column. One thing to keep in mind, they'll take spatial objects or data frame objects and you can start laying them in there. This is not like ArcGIS, which is going to do your projection on the fly to make sure everything lines up with each other. You have to have cleaned up that data and make sure that you are in the correct projections and the correct data types before you start trying to feed it into leaflet, or you'll have stuff all over space. So you can compose your maps. They're going to be using combinations of these background tile maps, which would be like Google Maps or Google Earth, or ones that you define and create yourself. And then you add on your layers of vectors, points, lines, polygons, whatever you have. It provides that familiar interface like you see when you look at Google Earth or MapQuest for panning and zooming. And again, you can embed them in Markdown or Shiny. And you can also use like in the other tools, use events when these interactive events to collect that. So if you click on a certain point, you can then pull that data for another interactive function and use it to drive actions in Shiny. So the basic interactive map, if you don't really give it any extra commands, library leaflet, we'll make our QMap object. It's going to be leaflet, give it the data, and then this, not everyone who works in R uses the pipe commands, but this % greater than % is the pipe command, just so you can pass the output of the first one straight into as input to the next one. So just makes for more condensed code. But so we don't have to actually fill anything into, it's the output from the leaflet that goes into the tiles, and it's that connects to the markers. So the markers are going to take the Latin long. We're going to give it a pop-up. So if you make this when you mouse over or click on the points, you just get a pop-up of, in this case, magnitude. But this is really hard to read unless you zoom in. All the markers are on top of each other. They're all the same color, so there's not much information there. So if you want to make something prettier, and I'll leave this as more code, but here what we're going to do is design our own color palette, and then instead of putting markers on there, which are by default that blue symbol, is to create our own, to use circle markers and to make them small so that we can see most of them. So first we define that custom palette, and the palettes that are used, that are most easily fed into leaflet are the ones from Color Brewer. So that's what the yellow, orange, red, YLORRD name there is in the color numeric function, and give it some domain for that range of the color scale from the minimum to the maximum. And then I create my leaflet map as I did previously, pass it the data, add the tiles, then add my circle markers using that palette that I made for magnitude. And then I decide I want a legend for it since I added my own colors, so add a legend, and I want to put it at the bottom right. Again, it matches up, the palette for that legend is going to match up to the palette I created, and the values are going to come out of the magnitude field, and I can give it a title. So it all, if you're familiar with R, it looks fairly straightforward. Functions with arguments separated by commas, and the help files are quite good in terms of giving you additional arguments that you can use to customize them. Yes. Yes, they should be on the GitHub. So if they're going, are they going by too fast or just to have them? Okay. Yeah, no, they should be on the GitHub as well. I've never put a PowerPoint on GitHub before, so I wasn't sure what it would do with it. But, all right, so are there any questions, actually other questions at this point? Because those are the 3 standalone kind of tools that, all right. There's a whole lot of other standalone tools, ggvis, rCharts, Google Viz, the leaflet R, network 3D. Each one of these tools connects to a JavaScript library. If there is a JavaScript library that you like to use for visualizations that doesn't yet have an R package to build the connection, you can go to library HTML widgets. This is the tool or the framework that was used to build the most of the existing standalone tools. But you can create your own binding and create your own tools. You can also create your own widgets. So different ways to interact with the graphics. If you didn't want to use a classic radio button or a slider bar and you had some other idea for an interactive feature, you could, in theory, design your own. Something I have not gotten that far in needing my own objects at this point. But and again, we'll come back to some of these links to show you some more visualizations at the end if we end up with enough time, but otherwise they're in here and on the GitHub. So the main goal was to build this shiny web app. And it's not going to be the world's prettiest app since we're building it all together, and I need to be sure that 1, the code fits on the screen, and 2, that it might actually work no matter what version of R that you have. But this is sort of our goal. So we're going to end up with a drop-down list and a slider bar. When we move the drop-down list, We're going to have some conditional features set in there so that we get different interactive features depending on what we want to see, which is what we pick in that drop-down list. We'll have a summary graphic that's interactive and the map that's interactive and the table that's interactive by the end. But where we start is with things a little more static. And we're going to build this first. And so the Shiny app structure it recently changed. It used to be that you had to create two files, a UI.R file, which would be your user interface code, and a server.R file that was all of your data stuff. This recently changed so that you could put it all in line, which seems to be so much better. It makes it much easier to embed them, for one thing, inside of our Markdown, and much easier to deliver them to someone else and have them successfully run it. This bit of code, these 4 lines, are the absolute minimum that you would need to make a Shiny app. It's not going to have anything in it, but if you type in these 4 lines and then highlighted them and ran them, you actually should in RStudio end up getting a Run App button when you type in all these lines. Once you install once you run the Library Shiny line, it'll run. It'll open an browser window with nothing in it, but it should do that, which is a good little test to make sure that the Shiny library is actually installed correctly. And then what we're going to do is we're going to fill in the bits in the brackets. And so basically the UI is again, the nested R functions that tell Shiny how to build the HTML user interface. So it's going to be telling where things go, how you want to define the page, what fonts you want to use. If you don't like the default, you can embed some CSS commands there to make things prettier, change your background colors and things. And then the server is all of the functions with the instructions on how to build that Shiny app. And you'll see when we look through it that we actually build like a Shiny object. So, and you'll be seeing these same codes again on pages, so hopefully we'll all stay together. If someone starts falling behind, I have no way to know that, so feel free to raise your hand and tell me to slow down. Probably if you need me to slow down, someone else needs me to slow down. So the Shiny app structure also has some rules about how files and folders are arranged. So you're going to create your app, and you're going to call it doesn't have to be app.r, but something.r, but it has to be inside a folder with all of these other things, if you have other things. So if you are going to have images, say, embedded in your Shiny app, then you need to have this www folder with your images in it. So the app R is required, everything else is optional. You can have other R scripts that are available to both the UI and the server. You can add in, it's always a good idea to add in description and README files. That would be text files in there. The www folder will have images. It'll have, if you have some other CSS code that you want it to call, you would put that in there. And then other files. So I often, to make my Shiny run faster, I have a lot of my data processing in separate R functions that I can call from inside my Shiny. So I would put those there, or I have R data objects that I've created that I can load up, and they would be these other files. If you were still using the older version for some reason where you have a folder with the separate UI and server R files, they would also have to be in that one folder, and that's part of how R knows to run them all together. Then if you want to deliver it to someone, that whole folder has to be zipped together and sent to them to be able to run the R from the R console. Otherwise, you're delivering it as obviously the app. But the default setup is kind of ugly. I never use it for real, but we're going to use it today. But it has a title panel, a sidebar panel, and a main panel, and this is sort of how they're spread out. So when you start adding code or text and pictures and objects, you're going to be adding them in one of these 3 sections in your UI section. So this will be where you can keep typing code, the bolded parts. So in theory, we have our code up above, which was our, load Shiny or library Shiny, and then we would load our data if we were actually loading it from someplace, but we're going to be using the internal data, so we don't really have to do that step. We saw previously that it was UI was a fluid page. This is what goes inside that fluid page for our default sort of layout. The title panel gives it some title, some text in there. A sidebar layout, which is a sidebar layout, has that sidebar panel and the main panel. And they're going to get whatever we want to put in them. Below that, we have the server object that we create. It's Shiny server function input output. And then it uses the curly braces because that part is a function that we're creating. And then below all of that will be the Shiny app. UI equals UI, server equals server, and that's just calling each of those objects that we just created. So I'll give a few seconds for people able to keep up and type things. And again, if you ran it just like this as it is, it would run. This time it would run producing a title and nothing else. All right. So we're going to add in up above your UI, make sure that you have these 3 green lines. So the library Shiny, we're going to add there the library ggplot2. And I'm also going to go ahead and make a data object just because it will be easier to type and keep track of as we go along. So I'll be calling it qdat. Might be easier if you call it the same for the quakes. And then also these yellow arrows indicate where you're inserting code. So the idea being that instead of this section that's in the highlighted yellow, you're going to end up with this expanded code. So it's keep the same wrapper on it. So this where it says sidebar panel, open parentheses, close parentheses, you still have sidebar panel, open parentheses, close parentheses. So hopefully it's easy to go through. And you might notice that this one is different from the code we already wrote. But so H3 is just a header 3. Give it some label. Then we're putting in a slider input. So the slider input is going to be the slider bar. Choices with slider bars are whether you want to have like one dot that you slide, so you're picking one single value, that would be like a threshold value maybe, or if you want to have a min and a max value, so you're specifying some range. This particular slider bar is a range slider, so we have to give it a min and a max value. The things that are in bold there, the input ID equals label equals min equals, these are all required for the slider bar to work, except for the last one, the step. You don't have to specify a step, which is the interval between each of the numbers. That could be left out, and R will try to find a default. It just doesn't always use the most logical default. And if you're familiar with, again, working in R, all of these, as long as you're entering these arguments in the same order in which they're specified in the help or when the code is produced, you don't actually have to use those bold words. So you don't have to put input ID equals. You could just give it its name. But for most of this, I've specified just so you know what you're actually entering. But when I write for real, I would leave out the input ID and the label words and not use those. So are people finished? Have something in there? So next is if we want to add, we made a slider bar, we're going to want to see some data. So this is, again, the user interface, so we're not creating a plot, we're simply saying where a plot is going to go. So in the main panel, I have the same thing from the, doesn't show my mouse. From the main panel, open parentheses to close parentheses, replace it with what you see in the yellow box. We're going to say plot output, open parentheses, output ID, histogram 1, so hist1, and then close the plot output function and then close the main panel function. And again, the output ID is optional. You could have just called it just put the hist1 inside the parentheses, and it would be fine with that. Optional arguments that you could add here would be if you want to have it have a specific size. I want it to be a square 400, pixels by 400 pixels, or 1 inch by 1 inch or something. So then we switch to the server part of your code. This is where you create and render the plot. So what we have to do is we have to say that we're going to create an object, and our object is going to be output, and then whatever the name is of our output. So our first output is that hist01. So output $hist01, that should look familiar, like you're creating an object that has the $sign for the different components of that object. And then to make the object, we're going to render plot. Let's open our parentheses, round parentheses, and then open curly braces because we're creating a custom function. And the first thing we're going to do is we made this slider bar so that we could subset our data. So we want to subset our data. So we're going to create I created qsub, which is simply the subset of qdat based on our slider input, the minimum and maximum, minimum being the number in position 1 of that vector, and the max being the number in position 2 of that vector, the vector being the input slider 1 meg vector. So, and then ggplot, because that works. So ggplot of our histogram, we give it our data, which is this data subset, qsub. It's aesthetic, it's a histogram, so just the one x variable of magnitude, geom histogram, and then give it some labels if you want. Now in this, you don't have to necessarily specify your x limits, but because we're making an interactive plot, as we move that slider bar around, our range of x values is changing, and what happens is your graphic is going to constantly have different limits, which means some of the benefit of making it interactive, which is seeing how the data change, your scale keeps changing, so you can't really tell how much effect you're having by choosing these subsets of the data. So I chose to fix my x scale from the minimum and maximum of the overall data set. So I'd only see my subset within that range. And I give it a title. And then the server's closed, you have your shiny app UI. If you have all that code, you should be able to highlight everything from, well, you should have the little run app button in the corner. I've found that some people don't always get that. If you have the run app button in the corner, you should be able to run it, and it should open up the window with the Shiny app. And otherwise, you can highlight the whole thing and run it manually. So, and just as a check, because again, how fast is this going? How many people have made it? One, not very many, it's two. How many people would like me to flip back through so that you have time to make it? And then we keep going. A couple?
So I grabbed the code from the GitHub.
Yep.
And it has render plotly rather than plot. And I tried to change it.
It won't do it yet, sorry, from Plotly. So if you're grabbing it from Git,
That render plot didn't work.
the render plot didn't work? So what's on, let me see for a second. Because this is, did it give a useful error? So if you're going to run it at this point, I'd be using the _PyData app because it's the first step of the 3 steps we go through. And if I do run app, so, and that was the code that I loaded up on GitHub. So we can take a look and see if it's different, but and I can make this view, zoom in. Still very tiny on there. So I'll get rid of, at the top you need to have library ggplot2 and library plotly, and the qdat equals quakes, but the whole thing otherwise fits there.
Yeah, I need the render plotly rather than just render plot.
Oh, it is. It should not be render plotly until the next step, but, and render plot shouldn't work. Oh, because I have library plotly. All right. If people haven't had it working, we can go ahead and put render plotly. All that happens is you'll get an interactive graphic instead, which was step 2. But it should, probably because it needs this. Library shiny maybe would be helpful. This is what happens when you build all the code and then reverse engineer it backwards into steps.
Yeah,
So,
I think the problem was in the main panel.
yep.
So I have to change plotly and output to plot.
And yep. Thank you, Zadie. So the 3 things I changed, we'll see if it runs, but it needs to have library shiny up there. Probably ran on mine because I'm always running shiny. Library ggplot2, I commented out for now library plotly. My plot out, instead of plotly output, it's plot output. And then instead of render plotly, it's render plot. So that's the first 7 lines. In mine, it's line 21. Oh, you can see my mouse, good. And then line 27. And in theory, so if it's in the middle of running and crashes, it needs to be escaped. So now we have our not plotly graph, so you can't interact with it, but you can change your data range for your magnitude. So close that. And if people want to see again, and actually while I'm here, I'll also show you can we see? No. When it made the graphics before the plotly, like the interactive objects, you can see that they ended up being lists with all of their different characteristics. So it's also another way that you can get it. What are the, if there's values in this list, such as aesthetics or data sources, it's places where you can go in, obviously, and substitute for other values. So go back to this. So there's a whole lot of other UI text entry codes. They look a lot like HTML tags. So header 1, header 2, text for plain text. Help text makes this small grayish text. Oh, thank you. They have a strong and an M for bold and italics. You can put in some breaks or some lines across your page. You can also use static HTML tags. There's a whole bunch of HTML tags that it will recognize if you use this tags $ notation. So like if you want to make an unordered or ordered list item, you'd use tags UL. And then you can also, in your text, embed hyperlinks and other things, so have people head to different places from within your app. Also, we made a slider bar as our input type in this one case, but there's a whole bunch of other called widgets that you could put in. So you could have a file input where when someone clicks in the box, it's going to open a window that says what data file do you want to use. You put a checkbox as self-evident. You have a bunch of options with checkboxes beside them. You can check them. You can do settings as to whether they can choose one or more of these items in the checkbox list. A date input, numeric input, select input we'll see in I put an example on the side where with a select input, which is the other kind of most common, especially if you have factor variables, is that you're going to select some factor, so you give it its ID, its label, and then you just set up the choices. So they get the text label that you'll want people to see, and then the value that they correspond to in your data frame, so total, male, female in this case. And then one of these has to be selected by default to start, so you tell it which one that is. Text input, radio buttons. Then you can also make these action items, so like a submit button if you wanted to play with all the interactivity. When we're setting up scenarios, people are building their own custom scenario, and then they can press a submit button at the end to have it all go off somewhere to someone who needs to review it. Or other action buttons that you can custom define what's going to happen when you do certain, when there are events in your interactive script. So there's also other UI outputs and render functions. They go in pairs. So we accidentally saw that there's not just render plot and plot output, but render plotly and plotly output. There's render table, matches with table output, text, text output. Render UI and UI output is one which will have, on an action, you actually change what people are going to see in the user interface. So it might be that you don't see a slider bar to make an option unless people choose in the previous step something that makes that slider bar relevant. And we're going to see a little bit, we're not going to render a UI, but you'll see a second way that's one way to do conditional elements within Shiny. We'll see a different, simpler way to do conditional elements in Shiny. But the output function is always going to be in the UI script, and the render function is in the server script, and they have to match up with their name with that ID. So let's say that we want to add a table to our main panel. Then in our UI script, right below where we put that plot output, we're going to have to make sure there's a comma after the plot output, because we're in this main panel function, we're going to add a second argument. The second argument is for this table output. So table output, and again, when we're saying where to put things, we just have to give them an ID. So this is going to be table 1 in my case. And then make sure there's no comma after that one, because it's the last thing in that panel, the last argument. Then we have to match it with a render command in our server. So underneath our histogram render plot, which I have the ... to shrink everything up. Underneath that, here you don't need a comma. These are each independent functions that you're creating, independent objects. So we're going to make the object output, or we're going to add to our server object the element for output table 1, and it's going to render the table, has to be both braces, the round parentheses and curly braces, and we'll just make it the subset of our data, something simple. So call it sub2, and you can copy paste the same code from previously, from our slider bar, again where 1 is the minimum value and 2 is the maximum value in that vector from the slider bar. And we'll see in a moment how to get rid of the redundancy that we just created between our plot and our table for calling data. And hopefully, if you're able to do that, you end up with something that looks like this. So it's the same as before, but with the table now underneath. And you'll see more, so if people can see the code. And then, so we made by default, we made a static table and a static graphic. We made but again, we can use, I said the DT library objects can be embedded in Shiny, the Plotly objects can be embedded in Shiny. DT actually comes with Shiny, so you don't have to load up that library if you're already in library Shiny. But all you have to do is change your table output and render table to be data table output and render data table. And as you can change the code back if you want to be, or if you didn't change it, just leave it like it was. from plot output and render plot back to plotly output and render plotly. But to run those ones, you have to actually have the library plotly enabled. So if you commented it out to test the previous code, make sure you comment it back in. And if you do that, it should look like, then it will match up with what's in the one, originally the one version of the PyDemo R code that was on the GitHub. So you might notice that we sort of repeated a step twice, that in both the histogram we made our data subset, and in our table we made our data subset. One of the things in Shiny is it can very quickly bog down if you're not being efficient, because every time you click on something, it's going to run certain sets of that code over again. So if you have the same data in each of these interactive render components, you might not be interacting with that plot, but when you click someplace else, it might run the whole thing. So they have advice on where to put things. You have to think about which things do you want to run once. Typically, you want to load your libraries once. You don't want to load your libraries every time someone clicks on something. Typically, you want to load the main data file once, or any scripts that you have, not reload them every time someone clicks on things. And so those are going to be outside your server functions. So these are like your blue things at the top. Then you have the things that are going to be run once per user or once per session. So that when they open the page and they browse there or press the refresh button, this particular code is going to rerun. So that's really what we want to do maybe with our data subset, that when they move that slider bar, that's the only time that code is going to run, not every time they interact with another part of the Shiny that we build. So these should be inside the server function, but outside the render functions. And we'll show you how to do that. So they have some examples here. If you made, another case would be if you had some constant maybe that you were going to use in all of your models. You only need to calculate that constant once and then use it in all the other figures. So my value or a data subset here were my two examples. Then you have the things that are going to be run often. They're going to be run whenever someone modifies that input. And so they should be inside that render function, or what we haven't seen yet, a reactive function or an observe event, which would be when you do something like if you lassoed your points on a graph and then you wanted to use that subset of graphs or a subset of points for something. So what we're going to do is we're going to take, previously we had in each of our, in our histogram and in our table, we had this qsub and qsub2 commands. So we can take them out of there, and instead where we're going to put them is, and just, I forget you can't see my mouse and there's no clicker. So here we have still our output histogram with its ggplot and the code that comes after that. We still have our output table, but notice that these have changed. Instead of being a qsub with all of the rest of the stuff, it's now just qsub with open and close parentheses. And here the data that we called is not our qsub data, but qsub with this parentheses. Awesome, thank you. So before we had our subset embedded inside each of our render commands. Instead, we're going to pull it out. So up above these two outputs, we're going to make a reactive function. So it's going to be an object, we'll call it qsub still, but reactive, open parentheses, and open curly braces, and then do our subset there. And what happens is when we call these, we have to call them, these are now then functions, so we call them with the open, they're empty braces because they're going to pull up the last thing that was made in that particular function. So, and these will run code whenever any input value changes, or instead of running it when any input value changes, they'll run it only when that particular slider bar changes, which can be much more efficient, especially as you get a bigger, shiny dashboard. And what it's doing is it's caching the values to reduce computation, and they can still be called by all the other code in your Shiny.
Is that new code in your
This should now be, it should be in the second one, so the 2 underscore. So we can look at it real quick to double check. But so if we scroll down for what it actually looks like, oh no, it'll be in 3, sorry. Which will have some other updates that we're still making, which is the conditional. But if you look down to where it is, oh, I added in the reactivity. We have one more step to do before it matches up. I didn't want to give you like 10 different PyData apps. But you can see it here with the data equals Q sub. Yeah, and this has one extra step in it because it's the 3 is the end of what it looks like. All right, and then so let's say that we want to, we're going to move the plot output, and then we're going to add a leaflet output where the plot was. So what we're going to have is we're going to add in our library leaflet at the top, otherwise it will break. So we add that in above our UI script, or our UI object. And then inside our UI object, inside the sidebar panel component, you see where we have our H3's text and our slider input. We're going to copy, paste, and move over the plotly output that we had, so this histogram one, so just cut it out of where it was and put it into this new area. And actually, one thing is get rid of that comma at the end, because that's the last item in the sidebar panel, so there shouldn't be a comma, there's no more arguments. And then in the main panel, go ahead and add an output for a leaflet output, and it'll be called map1. And that one does have to have a comma after, because the thing underneath it is going to have one more argument, which is the data table output, with no comma at the end. And then the leaflet, if you made it previously, is just the same code that we made before, or if you got halfway through and didn't finish, you can grab it and finish it. But again, we have our the output is going to be map1, and we're going to render leaflet to match our leaflet output in UI. We give it a color palette and then the Q map. If you wanted to make way less code or work for yourself, you could comment out the palette stuff. And instead of the add circle marker stuff, you could just, again, put in add markers. And okay. I'll leave that one up for a few more minutes. So the last thing that we want to add in is some conditional functionality. So as just an example of what this does. So it creates a panel that's going to be visible or not visible depending on what input the user provides. So for example, if you had a select input that was like pick a plot type, do you want to see a scatter plot or a histogram? When the conditional panel, if the condition equals the histogram choice, then we have a second select input that comes up, and it's going to be like, okay, well then, do you want to see a Sturgis, Scott, or Friedman method for the breaks? And then if they choose Scott, maybe a third conditional panel shows up, which asks for the actual values that you want to set the breakpoints at. So these two other panels didn't, if they had chosen scatter, then these two panels would not have shown up. You're still going to have to code all of those panels, obviously, in your server side of the script, but they're only going to be called and run if someone makes those selections. So looking at it with the examples that we have, so on your UI side, you would be adding in, so this is right below your, or between, you've got your, the first thing in your sidebar panel. So above the slider bar, slider input, you would add in these 3 items. The select input, call it select 1. It's going to be select earthquakes based on, and we give people a choice. Either select them based on the magnitude value or a depth value. And for default, we'd select magnitude. Put a comma, because that's the end of that argument inside the sidebar panel. Then we're going to give it 2 conditional panels. One is, this is the slider input that we already wrote, right? So the first one, which is for the magnitude values, we can just wrap in some new code. Conditional panel, where condition equals, and this is where you can tell that it goes out to JavaScript, and that normally we would have, if it was in R, input $, select 1, but this is actually taking, because it's in the double quotes, it's text value, but it's feeding that into the JavaScript when it's transcribing it to JavaScript. So Java uses the dot for separating the object and the variable in the object, or the item in the object. So it has to be a dot here, and that can be important to remember for all of this stuff shiny. If you're someone who, by default, tends to name your objects using dot as opposed to a mix of capital and small letters or underscores, you use a lot of dots, it can end up being a little confusing to JavaScript when you then start embedding things in Shiny or these interactive apps. So I now just default to underscores or mix of caps and small letters. And then it's important that your, in this case, whatever your variable is, ends up in, if it's a text variable, that it have the single quotes. Normally R doesn't care about single quotes or double quotes. You can write all of your text in R embedded with single quotes or with double quotes as long as you're consistent. But if you're going to write the Shiny apps or some of these interactive, because JavaScript apparently cares, use double quotes for anything that's R text and single quotes for anything that's being passed to JavaScript. Just 2 little things that if you don't know that, it can take a long time to debug what on earth are you doing wrong in your command. But so you can copy paste in the first slider bar and then make one that looks almost the same, copy paste and modify the code. So your second conditional panel that would pop up if they chose depth is if that condition equals depth. Then it's the slider input 2 is going to be a depth. We'll call it slider 2 depth with a label, show earthquakes of depth. And the min and max values have to change to be calling from the depth column of the data frame. And the values also have to be calling from the depth data frame. And also because this depth is in kilometers, not in point values on the Richter scale, you probably want to change your step value as well for this second slider bar. It's funny, every time I teach any sort of coding, I always wish I could have everybody have some sort of wired buzzer so that they just, or not buzzer, but like something that pops up, a counter, like when you're finished, you hit it, and then when I get to a certain amount of percentage people being done would be when I move on. It'd be so much nicer if someone wants to develop, those are different kinds of app skills than I have. Someone wants to develop an app where my phone would keep track of, people could press in, that'd be really cool, I would buy it. So we have 2 conditional panels. Now we have to go and modify that's in our UI script or object. So now we have to go modify our server object, which is a little easier. But so here we have our data object that we're going to create. It's going to be reactive still. But now we're going to put in an if-else statement. There's a couple of different ways you could do this. I did this because it's probably familiar and fairly easy to code because you can copy paste and take advantage of repetition. But so if the input from select 1 is the magnitude value, then the subset is going to be subsetting based on magnitude, the slider inputs from the magnitude values, or if the subset is from the depth, which was the other option, then we're going to be pulling the subset based on values in the depth column. And then after our else statement, we just have our data because that's what's going to get returned when we run q sub open close parentheses for that function. And you can make your life pretty easy by like copying and then pasting and then just making the modifications of depth versus mag. So in theory, if you run that, you end up with what we have, what we showed at the beginning. That's what we were basically trying to make. I'm going to escape out and run this one. So one of the things that we'd obviously go in and start trying to edit the graphics. I'd like to have north arrows on any map that I make. I like to have numbers that don't overlap each other. Lots of things we can do to make it prettier. Probably would want my circles to maybe size on a second variable if that was important. But the main features being we now have conditional functionality so that as I change from depth to magnitude, the slider bar that I have changes. And then when it's now showing a huge view. Oh, not that. I can't make it smaller. But if I change the size of my earthquake magnitude, I'm getting changes in all my other data panels. So I'm seeing a different histogram. The number of dots have decreased because I'm looking at fewer. My value for the scale has changed. One thing I might want to do is to set that to a constant color scale, so as I reduce my range, the colors still stay consistent. And I have a basic interactive table where people can sort on things or search on things. Now, usually when I'm making these because I have some question in mind, or my clients have some question in mind, or some story they need me to tell, so there's more text. The top of this would be the answer to the question that they were posing. So, there is or is not a correlation, and you can take the values from your data. So if you're reporting a mean, you could have text where you paste together, just like you do currently, presumably in R, where you paste together text that says the mean value for this data subset is, and you would have a reactive text component where you render text, and the render text is a paste of, the mean value of this subset is, and then you're pasting in from that q sub reactive data set the mean of whatever column you want to find the value of. And again, because you're pulling from that same reactive data set for these summary statistics, you're not having to run that every time someone opens or every time someone clicks someplace else, only if they change that slider bar. And let me go back to So I'm going to go, I didn't know how long it would take to go through things, and also I can end up taking a lot more questions. But I wanted to show you some of the pretty things and some of the resources then, since I have time, that are going to be more useful to you than just me giving a broad overview. The ones that I've showed you, Plotly, DT, and Leaflet, all have cheat sheets, which are really nice. A lot of times when I'm teaching, I actually have to be offline, and those cheat sheets become indispensable as a resource, so I use them a lot. Also, though, each of those have their own galleries. So there's a Shiny gallery as well as a Plotly library, and Plotly are examples. They all have tutorials online, both free and paid if you want to take paid things. There's obviously Shiny has really great tutorials that you can walk through step by step from your hello world to your pretty app. And Google searches, the one thing I would recommend that because these are evolving so rapidly that if you're going to do a Google search for help on any of these packages or for an argument within these packages, that you add some year like 2015, 2016, especially if you use ggplot2 because there was a major update at the end of ggplot2 and a lot of the functionality changed in terms of how it interacts with Shiny. So just something to keep in mind. And then what I'm more comfortable doing than in like these kinds of workshops is I do a lot of tutoring in workshops. So if anybody wants to come spend a week in Barcelona, Spain, for a week of interactive where you get to bring your own data and build your own Shiny from scratch with your data and your question, where we start with storyboarding, it's a lot more fun. But let me just, well, first if people have some questions, otherwise I'll show a few demos and I can even, these people have questions. And then I might reserve the right to ask my questions of you if we go through, but let me find.
So I had a question. I think you answered it. I just want to make sure. In your copy, one thing that I never found a way around was to be able to edit the text that comes up in the banner.
Okay, so the question is whether you can edit the text in Plotly. So if it's in Shiny, I know I could do it because what I would do is I would be building any text I see inside ggplot, and I know how to edit all that text already with ggplot, and then I would use ggplotly. Now I haven't had to do that where it mattered, so I don't know if ggplotly would revert it, would maybe strip out some of those custom annotation settings, text annotation settings that I'd put in. So I would default to what I know. So the short answer is I don't know the answer to your question as to whether you can in Plotly. I would assume so, though. I mean, your other option would be, so with all of these tools, you can edit things in R from that end, or again, you can modify with JavaScript. So it's transcribing information from R into JavaScript. So if you don't like that setting that JavaScript is called, and then putting it into HTML for the website, you can also edit things in the HTML CSS files about default text. But I've not ever had a case where I'm building those tools as standalone. They're always in Markdown or they're always in Shiny so that I can give them to someone else, unless I'm just looking at them to see if they work, and then I don't care what text I see. But other questions? So the question is how difficult is it on my local machine versus production? Okay, so the place where I take these two is I build them on my local machine, and then I'm either serving my stuff up on a Shiny apps.io account. So I can actually show you, so like I haven't published it because I wanted to be able to show you. So if I hit publish, it'll ask me what I want to publish and where I want to put it, give me the choice of all the files in that folder. That's where they have to all be together because that's the only folder it's going to look at. It tells me I have something wrong with that one. Publish anyway, we'll see if it goes. Nope, it didn't want to go for some reason, which, is that plot 3? Try the simpler one. Oh, it probably won't do it because I have all 3 R code in the same folder for teaching. I'd have to clean it up a little. And that one's not a Shiny. But in terms of production, so I've built them using, like on Amazon, when I had more data and needed more power on Amazon Web Services, building up Linux machines. But I don't think that's what you mean by production. When I've delivered it, I've been able to deliver, they've wanted the Shiny app at the end, and then I give it to Fish and Wildlife Service or to the state or whoever, and they don't have R, but they're they're just taking that website that I built, that I've put on Shiny Apps.io. Or I'm wrapping up everything that I made with R and giving it to their web developer who knows JavaScript and CSS and HTML, and they're somehow embedding it into the Fish and Wildlife Service endangered species site. And I'm not sure what all goes into that. I have a colleague in Australia who does it when that needs to be done. So, but you're not, a couple people have asked me, so I'll have to find out even if it's not something that I regularly do. My clients just aren't that big. My data's not that big. It's more like Swiss cheese data than big data. And a lot of what we're doing with the Shiny tools is actually figuring out how to fill those Swiss cheese holes, what sort of assumptions make the data look reasonable by doing visualizations and scenarios based on different assumptions and values for filling gaps and using expert knowledge. So probably a different context than a lot of you use it. Other questions? Let me just show real quick. So the Shiny website, if you haven't been there, presumably you probably went if you were signing up to take this course. But one is that it's very basic, it's free, but it will definitely walk you through everything in an easy way, is their Shiny tutorials. It takes a couple hours maybe to go through. And it's a really good starting point, especially if you already know R and aren't starting with Shiny, but are starting from having used R. The other thing, though, is in their gallery, they have all of these examples, and all of these are working examples where you can find what you think you might want to build. And it's slower here, but what they give you is, you'll see the graph, the interactive feature, and then because this was created a while ago, they do the two scripts. So you've got the server R script and the UI R script. There's a few differences in how those are set up. But the main components you could just copy and paste straight into your own Shiny script and they would run. And they all use the free data that comes with R, so they're all ready to go. Same with if you look in R down in the help, so if you typed in, like leaflet output down the bottom of the help, you'll see example code that you can immediately copy paste and run to get an idea of the framework that you need to use to then make your map run in leaflet. And whenever I've put up questions on the various like R help sites and Shiny help sites, I've usually had an answer. There's only been once that I didn't have an answer within 24 hours where someone had offered some helpful guidance on my code, which is one of the main reasons that I also really like working in R, because it's a good group of help. So, oh, and actually one other thing is, I think it's under reference. So reference has this long list nicely organized from things you might want to do with your layout, things you might want to do with your input, outputs, events, and rendering. Just click on them, and again, you'll see a working example for that component of the code. And stuff that I obviously don't cover in the beginning, but like the extending it, so creating web dependencies, resource paths. One of the fun things is when you start getting events so that you have your layers of interactivity. So you have an interactive leaflet map embedded in an interactive Shiny, and when you interact with the leaflet map to say select points, that's changing what's in the table. You can quickly get several layers of conditional statements. So the other big one that I mentioned, Plotly, is Plotly for R. Plotly has always been great in JavaScript. Plotly for R connection is getting bigger and bigger and doing more and more. They also have some tutorial material and a whole gallery of things that you can produce that along with their code, so that you just have, basically the easiest thing to do is to find an example picture of what you want to produce, like here you go. and then copy the code, the sort of usual way of working in R. Someone has built it. And again, with the caveat, find someone who's built it recently, since this stuff is still updating quickly. And I think leaflet, and these are all just if you Google leaflet. And then data tables has all the different code for all different things that you can do, from changing the colors, changing the names, changing order and structure of the data. So, and if you, in these examples, they'll also give you ideas of how the HTML and the CSS and the JavaScript interact with R in some of the examples. So I'm actually done early. That was what I had, unless people, again, have questions or... Well, thank you. If anyone didn't get it finished but wants to